Hello everyone, thank you for watching my video today. And in this video, we're going to start taking a look at graphing logarithmic functions. All right. So to start, let's talk about its connection to exponential functions, because remember they are inverse functions. All right. So if f is exponential, then its inverse is going to be a logarithmic function. To graph the function of f inverse, we exchange the x and y coordinates of f. The domain of f becomes the range of f inverse and vice versa. The graph of f inverse is a reflection of f across the line y equals x, i.e. it's a line of symmetry. Okay? So if I was asked to graph these two functions, let's take a look here. We're going to do 3 to the x. So y equals 3 to the x in blue here. 3 to the negative 1 would be 1/3. 3 to the 0 would be 1, and 3 to the 1 would be 3. So let's plot those points. With the asymptote at y equals 0. Okay? So for a logarithmic function, we're going to do this one in red. If I was to rewrite this in terms of exponential, it would be 3 to the y equals x. Right? So now if I plugged in y as negative 1, 0, and 1, I would get the x's back of 1/3, 1, and 3. So if I plot those points, 1/3 comma negative 1, 1, 0, and 3, 1, I would get a graph that looks like that. All right, and then if I was to draw in the line y equals x right here, that should act as a mirror between the two graphs. Okay, so again, remind you that the exponential one would have an asymptote at y equals 0. Therefore, the logarithmic function would have a vertical asymptote at x equals 0. Okay? So down there at the bottom for logarithmic functions, remember that log base b of x defines a logarithmic function of x with base b. As always, we can use a table of values to help us graph any function. Since b is not 1, it seems reasonable to graph an example where b is greater than 1 and compare it to one where it is between 0 and 1. Okay, so let's do that. So we have that same one we just did here, 3 to the y equals x. So our values were 1/3, 1, and 3. So it'll be 1/3 negative 1, 1, 0, and 3, 1. Okay, so we call this logarithmic growth. And that is when the base, b, is greater than 1. However, over here, if we were to rewrite this, it would be 1/3 to the y equals x. So 1/3 to the negative 1 would be 3. 1/3 to the 0 would be 1. 1/3 to the 1 would be 1/3. If I was to plot those points, I would get this graph. And we call that logarithmic decay. And that's when b is between 0 and 1. What do these things have in common? All right, so there's a couple things that they have in common. The vertical asymptote is x equals 0 for both of them. Okay, the x-intercept is 1, 0 for both of them. The domain for both of them is the same. Okay. The range is actually the same as well. It will go up forever and down forever, so the range is both. Okay? And then the base itself, even though it's changing, we know that there's going to be a point of base comma 1. All right, so quick note here. The square root of x, we should know that it actually means 2 to the root of x there, that little 2 up there in the superscript. We just don't write it very often. It's like putting a 1x. You don't put the 1. You just, if we write x, we assume it's 1x. Okay, so if it's a square root, we don't put the 2, but if it's any other root, we would put it. This is similar to logs with base 10. Base 10 is used so often that if we just write log, we assume it's log base 10. And also, we've talked about this before, log base e we know as ln. All right, so finally, graphing logarithmic functions. First, again, write the rule out, identify all transformations that we're going to look at here. Identify 3 points. You can start by graphing the parent function. It does help, okay, and then graph the transform curve as well. Write down the asymptote and identify the domain and the range. All right, so let's take a look. Let's start with our base function. Our base function is y equals log base 4 of x. So that would be the same as writing 4 to the y equals x. So 4 to the negative 1, 4 to the 0, 4 to the 1. So let's start by plotting my base function. With a dashed line, of course, since it's not the actual graph here. So that's my parent function here. Okay, so what's happening in this graph? Is there a reflection? No, no reflections. Is there a horizontal shift? Yes, we go left 1. Vertical shift? No. The asymptote, since we are moving left here, the asymptote moves with it. So that'd be x equals negative 1. The domain also moves with it, but the range stays the same. So our rule here would be xy is going to go to x minus 1 y. So all we're doing is taking those 3 points and moving them left 1 along with the asymptote, and our graph should look like that. Second one, my base function is y equals log base 3 of x. So that could be written as 3 to the y equals x. So it'd be 1/3, 1, and 3. Let's plot those. 1/3, negative 1, 1, 0, and 3, 1. There's my parent function here. All right, so there's no reflection. There's no reflection. We're going to shift right 2, and we're going to shift up 1. So the asymptote then is going to shift right 2. The domain is going to shift right 2. And the range, of course, is going to stay the same. So my rule is going to be x plus 2, y plus 1. So we're going to add 2 to the x's, add 1 to the y's. So at this point, 1/3, 1 is going to move right 2, up 1. Right 2, up 1. And right 2, up 1 from that third point. And our graph's going to look like that. Third one, our base here is the same, log base 3. So I'm doing a little cheating here. Work smarter, not harder, right? So my 3 points for my parent function is going to look the same as last time. Okay, so now reflection over x-axis. So is there a vertical reflection? There is. There's not a horizontal one. We're going to shift left 5. We are not going to shift vertically. This one actually has a horizontal stretch by 1/2. Okay, or a compression if you want to call it that. The asymptote this time is going to be moved left 5, then also multiplied by 1/2. So it's going to be negative 5/2, which means our domain is negative 5/2, comma infinity, and our range again will stay the same. All right, so the rule for this one, xy, is going to go to x minus 5 over 2 negative y. X minus 5 over 2 and then negative y. So, first of all, actually you're going to plot the vertical asymptote for this one. It's going to help. This is a tougher graph here. All right, so we're going to move left 5, and then cut it in half, and then flip the y over. Okay, so left 5, and then cut it in half. 1, 2, 3, 4, 5, cut it in half. And then flip the y over. We should be somewhere around there for our first point. Next point, move left 5, and then cut that in half. And then flip the y over there, so it'll just be 0 again. So it'll be right around there. And the third point, if we move left 5, and cut that in half, and then flip the y over, it should be right about there. Okay, now what you can actually do here, remember, is take these 3 points and put them into this rule. That's why we write the rule out. It'll make it a lot easier for you if that's something you need to do. All right, last one, log base 4. So no cheating this time. We got to do the work. Y equals log base 4 of x. So 4 to the y equals x. Be 1/4, 1 and 4. So there's my parent function here. There's no reflections. We are going to shift left 3. We're not going to shift up or down. We're going to stretch this by 2. It's actually not horizontal, though. It's actually vertical. By 2. So the asymptote, since we moved left 3, is going to move left 3. And then the domain will move left 3 as well. So my range is going to stay the same. All right, so my rule for this one, pretty straightforward. X, y is going to go to x minus 3 to y. Okay, so again, I'm going to go ahead and I'm going to draw the asymptote in at -3. Okay, and we're going to move the points left 3 and then multiply the y by 2. Our graph should look like that. Okay, that will do it for our lesson today on graphing logarithmic functions. I hope you enjoyed it, and we will see you again soon.